In 2015, the space community was buzzing with excitement. Until that point, the most impressive image we had of the Pluto system was this one. While Hubble attempted to capture Pluto with its lens, its small size and great distance rendered its observations little more than a few indistinct blobs of color variations. However, everything changed in 2015. This shift occurred when the New Horizons space probe completed its 9-year journey and flew past the dwarf planet, offering an unprecedented level of detail and clarity of Pluto and its moons. This raises the question, what did the New Horizons probe discover during its flyby of the Pluto system, and what activities has it engaged in since? Stay with me throughout this video as I highlight the remarkable moments from the New Horizons mission to Pluto and beyond. Before diving into the details, let's provide some context for anyone new to Pluto or those who may need a refresher. Pluto is an incredibly beautiful diminutive world, significantly smaller than our moon. It resides in the Kuiper Belt, a sparse expanse populated with asteroid or comet-like objects situated beyond Neptune's orbit. Pluto was the last of the traditional 9 planets to be explored, a situation attributable to its distance from us, and believe it or not, it had not been deemed a particularly intriguing celestial object. Fortunately, the team behind the probe advocated vigorously for its mission approval, resulting in the launch of New Horizons in 2006 under NASA's New Frontier program, which targets medium-budget space missions. The mission aimed to reach Pluto promptly, leading to New Horizons being the fastest launch ever, as it was a lightweight spacecraft propelled by the most powerful rocket available at the time, the fully boosted Atlas V. New Horizons zipped past the moon in just 9 hours, 10 times faster than the Apollo missions. On its journey to Pluto, it utilized Jupiter for a gravity assist, which cut the arrival time by 3 years and served as a trial run for its systems, capturing astonishing videos and images of the gas giant and its moons. Following this successful test, New Horizons entered hibernation mode to minimize instrument wear. As the approach to 2015 drew nearer, the team activated the systems, and every day the spacecraft transmitted images of the Pluto system. This period was exhilarating for enthusiasts tracking the saga. Hints of Pluto's possible appearance began to emerge, allowing us to observe the stark differences between Pluto and its largest moon, Charon. With each passing day, the resolution improved, revealing more intricate details. An eye-catching, heart-shaped formation became discernible on the dwarf planet. On July 14, the New Horizons probe made its closest pass, coming within 12,500 kilometers of Pluto's surface. However, mission controllers didn't gain immediate access to the data. The probe was busy capturing numerous images during the flyby and was unable to transmit them right away. Once data transfer began, they faced the challenge of a slow uplink speed of only 1 kilobit per second, along with a 4.5-hour delay between the spacecraft and Earth. Nonetheless, the data received was incredible: mountain ranges, ice plains, glaciers, and an atmosphere. It also provided an extensive look at Pluto's moons. Let's delve deeper into its findings during the flyby. One of the first notable observations about Pluto is its peculiar relationship with its moons. For starters, Charon, Pluto's largest moon, orbits closely and is significantly larger in relation to Pluto. This proximity means that the barycenter, that is, the center of mass, of the two objects lies outside of Pluto, resulting in both bodies orbiting around a point in space with each being tidally locked to the other. This means that if you were standing on one, the other would remain fixed at a point in your sky. Such a relationship is unusual since while some moons are tidally locked to their parent planet, The planet typically isn't tidally locked to the moon. Visually, Charon stands apart from Pluto, appearing much darker, indicating they likely have different origins. Pluto's other moons are relatively tiny, only a few kilometers across, characterized by exceptionally circular orbits that are coplanar with Pluto's orbit. Pluto's geology is fascinating. The most prominent feature visible is a massive heart shape that captivated the world upon its unveiling, named Sputnik Planitia. This heart-shaped region is as large as Texas, and exhibits a striking color contrast with its surroundings, primarily due to being a vast ice plain. During the flyby, it was established that an overwhelming 98% of Pluto's surface consists of nitrogen ice. The average surface temperature on Pluto is around -229 degrees Celsius, which means water ice would be incredibly rigid and brittle. Conversely, nitrogen ice at this temperature behaves more like water ice on Earth, allowing it to flow as glaciers. This flowing can especially be observed around the heart's edges, where glaciers pour into the spaces around craters and mountain ranges. The shapes of the ice plains exhibit enormous polygonal patterns throughout the region, and the absence of craters suggests that this is a relatively young feature, or one that undergoes continual renewal. The polygonal cells display ridges likely formed by sublimation, where ice transforms directly into gas. This sublimation and freezing cycle occurs frequently on Pluto, creating troughs and pits, indicating these polygons likely function as convection cells that are shifting and draining into the mountain ranges through slow-moving glaciers. Sputnik Planitia bears similarities to Greenland and Antarctica, in that it plays a significant role in Pluto's climate. While its accurate formation is still a matter of speculation, it may have come from an impact that created a crater, later filled by ices from a potential subsurface liquid ocean. This filling results in a positive gravitational anomaly, where gravity at one point diverges from other locations on Pluto. The ice plane is oriented directly away from Charon, aligning with the tidal axis with strong tidal influences due to their close proximity. This connection may explain why Pluto is tidally locked to Charon, leading to the two bodies always facing each other. Surrounding the ice plains are towering mountain ranges made of water ice that produce stunning views when seen from the side. Among these mountains may be some cryovolcanoes, with Reitmann's being a potential candidate. Standing at 4 kilometers tall, this peak is one of Pluto's highest and hosts a significant depression at its summit. Cryovolcano activity could contribute to the relatively youthful appearance of Pluto's surface. Another intriguing area is Tartarus Dorsa, encompassing a distinctive set of mountains approximately 500 meters high that resemble snakeskin or tree bark, thought to be known as penitentes. If confirmed, this would make Pluto the only other location in our solar system, aside from Earth, where these features have been noted. Although rare even on Earth, some penitentes can be found in the Atacama Desert and other dry, high-altitude regions, while those on Pluto are both taller and spread over a much larger area. We can only hypothesize about their appearance up close. A prominent characteristic of Pluto is the dark material seemingly scattered across its surface, most notably in an area referred to as Cthulhu Macula. Its peculiar shape is reminiscent of a whale. Cthulhu Macula is far more cratered than the heart region, suggesting an older surface. Mountain ranges emerge within this area topped with what is believed to be methane ice, which condenses as frost at Pluto's higher altitudes. Scientists theorize the dark coloration results from Tholins, tar-like substances comprised of hydrocarbons altered by sunlight. Similar deposits have been observed on Iapetus, one of Saturn's moons, indicating that this process occurs elsewhere in our solar system. Upon receiving initial images from New Horizons, scientists quickly suspected that the dark material was Tholins, yet their uneven distribution across Pluto puzzled researchers. Why are certain regions covered while others remain untouched? Moreover, how dynamic is the distribution of Tholins? Have they existed this way for an extended period, or is Pluto's environment in flux? It appears that Tholins may indeed be linked to the cryovolcanic activity on Pluto. Pluto is among the few objects in our solar system with cryovolcanoes that actively impact its landscape. Eruptions from these cryovolcanoes release water, either from the mantle or pockets within the crust, across Pluto's surface, producing a diverse terrain. Importantly, these eruptions also incorporate tholins within the ejected material. Data from Hubble indicated that Pluto has been growing redder, and new horizons may have arrived at the peak of this reddening during Pluto's annual cycle. In a region dubbed Viking Terra, a cryovolcano appears to have erupted, spraying a mixture of water and tholins across the area. Nearby, craters and troughs filled with this slurry material can be observed, revealing its flow patterns. The most noteworthy discovery about tholins isn't confined to Pluto, but extends to its twin dwarf planet, Charon. In a color-enhanced image of Charon, you might notice the reddish cap adorning its northern pole. Remarkably, due to Pluto's weak gravity, some of the tholin-rich slurry ejected during eruptions escapes Pluto's gravitational grasp, traveling a distance of 19,000 kilometers until it lands on Charon. As Pluto and Charon are tidally locked to each other, they perpetually reveal only one face to one another, resulting in concentrated tholin deposition on specific spots on Charon. Poetically, Pluto conceals its heart from Charon in an eternal dance. Charon has also proven to be an object of interest. Unlike Pluto, which primarily features nitrogen ice, Charon is characterized by a surface dominated by water ice. Consequently, Charon lacks an atmosphere similar to that of Pluto, as its water ice remains firmly locked to the surface. The atmospheric density on Pluto can fluctuate wildly throughout its lengthy seasonal cycle due to the sublimation and refreezing of nitrogen ice, contrasting with the tightly clinging atmosphere around Earth thanks to its stronger gravity. The impressive discovery made by New Horizons was not merely the confirmation of Pluto's atmosphere, but the incredible details captured in the images. Even though Pluto is much smaller and less massive compared to Earth, its atmosphere appears to extend significantly above the surface. In contrast, Earth's atmosphere is much denser and more massive, hugging the planet tightly due to stronger gravity. Pluto's atmospheric pressure is exceptionally low, measuring around 10 microbars, or 100,000 to 1 million times weaker than that of Earth's surface.